So, today we will be identifying line symmetry within shapes with some shapes who have one or more line symmetry. And so, you're probably asking, what is line symmetry? So, line symmetry is relation to the dashed line. That is called a line of symmetry. So what does that mean? So imagine you had a piece of paper and you folded it in half. Well, that's exactly what it is. When you fold it in half, it's equal on both sides. So, for example, let me just show you what I'm talking about. So we have this rectangle like this. So if we take this rectangle and we fold it this way, and we fold it like this, you notice that it's equal on both sides. So this is the line of symmetry. Now, this rectangle has more than one line of symmetry. If we look at it, when we fold it like this as well, it's equal on both sides again, once again. So, once again, there's a line of symmetry right here. Now, as I've said, some shapes have more than one line of symmetry. So, what we're going to do is we're going to look at a few shapes on the board. What we're going to do is we're going to look at a few shapes on the board, and we're going to go over some line of symmetry so that you can see exactly what I'm talking about. So, let's start off with this. So, this is the line of symmetry right here. So, if we draw this, we will have to have the other half of the heart. So what we do is we will draw the other half of the heart. So that's one line of symmetry. Now, let's look at this. If we decided to go right here, would that be a line of symmetry? No, I don't think so. Because if we look at it, once we fold it according to this line, it is not equal on both sides. So that is not a line of symmetry. Now, let's go to another shape. Let's look at a equilateral triangle. An equilateral triangle. Now, once again, we have one line of symmetry so far, and that's right down the middle. And that's line of symmetry for the reason that when we fold according to this line, that once again, they are equal on both sides. Now, if we try to do it this way, that would not be a line of symmetry. Why? Because it wouldn't be equal on both sides. So far, this shape has one line of symmetry so far. Now, let's try a circle. So, here's the circle, and so we have to draw the other half of the circle. So here's the other half of the circle. So, that's not a good line, right? Let me clean that up a little bit for you. Now, that looks better. So far we have one line of symmetry right there. But, if we draw another line of symmetry right here, if we look at this, can you see if that's a line of symmetry? Well, yes, it is. Because if we fold according to this line, once again, we're equal on both sides. Now, if we look at it again, so far we have two lines of symmetry. Notice, we have one right here and one right here. Because if we fold this way, they're equal. If we fold this way, they're equal. Now, if we go this way, if you look at it, once again, those are equal. If we fold according to this line, they will be equal on both sides. So, as I was saying, some shapes have one line of symmetry, like we said right here and right here. And while other shapes have more than one line of symmetry. Because this circle has so far 3 lines of symmetry right there. So, what I want you to do is, I have prepared a worksheet for you. I have prepared a worksheet for you guys. So what I want you guys to do is I want you to take a few minutes and I want you to work on this worksheet while Janie comes up and teaches you a little bit about triangles in geometry. So just take a few minutes while Janie gets prepared. Okay, class.
Good morning, class. As Jaleah said, I'm going to teach you a little bit about geometry and measurements today. Today we're going to work on applying what you know. I'm going to go over a little bit of, real quickly, a review of what you know, what you've already learned in your angles. So, when you learned about an acute angle, your acute angle was less than 90 degrees, correct? And your right angle was exactly 90 degrees. And obtuse was more than 90 degrees. So let's talk about this real quick on a circle. A circle, how you get this is a circle is exactly from here all the way around is 360 degrees. What is half of 360? Half of 360 makes a straight angle, which is 180 degrees. Let's put this over here real quick. 180 degrees equals 1/2 of your circle. If you were to cut a circle in fours, each one of these fours, what times what equals 304? What times 4 equals 360? 90. This is 90 degrees, 90 degrees, 90 degrees, and 90 degrees. So you have 4 right angles right here because it's exactly 90 degrees. 4 right angles in a circle. If you're going to talk about an obtuse angle, as you can recall, an obtuse angle is more than 90. Here's a 90. An obtuse angle is more than 90. So all this is more than 90. Let's say this area is a 95 degrees. So this is what you're looking at. It's more than your 90. So we're going to move on, and we're going to learn today about acute triangles, about the triangles part of the angles. It's just like you learned in your angles. If you were to take, we're going to apply what you've learned. If you take this acute angle and make it like this, your acute angle is less than 90 degrees, which means each one of these degrees here are less than 90. See, like 30 degrees, 40, and let's say 45 degrees. This is an acute angle, acute triangle. A right triangle is exactly 90 degrees. And in a right triangle, what do you have here? You have one right triangle, one right angle. You see this? One right angle, same as this, one right angle. So this would be our 90. And then you have two what? These are less than 90. So it would be our two acute angles. So a right triangle has one right angle and two acute angles. Simply by taking what you know and applying it to what you learn. An obtuse triangle, okay, an obtuse triangle is more than 90. So this is a 95, because 95 is more than 90. So we have one obtuse, because it's more than 90, right here. This would be your obtuse. And what do you have here? So this is a 45 and 80. Would 80 be an obtuse? Would it be a right triangle or would it be an acute? It's less than 90, correct? So you would have two acute angles. And this would make your obtuse triangle. So I hope you have a worksheet in front of you. It's called Identifying Triangles. Let's work together and see if you can. I'm going to work number one, problem number one. What would you say problem number one would be? Problem number one looks like this. What would you say it would be? Is it equal to acute? Is it acute? No, it's not acute. Because see, there's our 90. Is it a right triangle? Do we have a right triangle here? Yes, so this, problem number one would be a right triangle. So if you want to work on the rest of this worksheet in a class,